Hi all, my name is Dhruv Sharma and I welcome you all on our next session on VMware NSX T-Shoot. In this session, we'll be focusing on three techniques how we can troubleshoot our network-based problems when we are deploying NSX. So we will not be discussing about what NSX is, what functionality or the features. We will be purely discussing on techniques how to troubleshoot network-based problems caused due to NSX firewall. Let's jump in. We'll be discussing about three techniques. First, the packet capture, trace flows, and the live logs. Guys, if you're working in a network-based environment where you have been using firewalls, routers, you must have performed packet captures by now. Packet captures are used as a good technique to troubleshoot any problems where the traffic is not reaching from source to the destinations. So we will be using this technique of packet capture, and I will tell you how you can use this tool in your environment. So you can see these commands in your slide, which you can use in your environment to perform packet capture. We'll discuss these commands briefly in a live demo, but if you notice within these commands, I've highlighted some capture points in red color. These capture points are nothing but the area where you can perform packet captures to capture the right traffic at the right moment, because this will help us to narrow down the problem in your environment. So these capture points, which I highlighted in my previous slide, are also being highlighted in red boxes. So I will explain you how these capture points will going to help you to troubleshoot the environment. So let's suppose in my lab I have two ESXi hosts, .191 and .192, and the traffic is being sent from the VM CentOS to web server. This CentOS is hosted on 191 and web server is hosted on 192. When the traffic is sent from CentOS, it hits the NSX distributed firewall. Then it goes through NSX virtual distributive switch, goes through the encapsulation engine, which encapsulates the traffic using the TAP IP, using Genevieve. In my case, the TAP IP on ESXi1 is 10.0.0.1, and over here is 10.0.0.2. And traffic is finally sent through the physical wire. So over here, NSX gave us three opportunities to perform packet capture. The opportunity one is the Phoenix TX. This is where you can perform a packet capture right just after the VM sends traffic towards the distributed firewall. The packet capture opportunity 2 is where the traffic has already came out of the NSX engine, that is after the distributed firewall and through the NSX virtual distributive switch. So this capture is point 1 and point 2 are extremely important, guys, because over here we can see if you see a packet capture at point 1 and doesn't see traffic at point 2, it is evident that something is not right or at DFW or at NSX virtual distributive switch. And finally, the third opportunity is the uplink, where you can see the traffic being sent after the traffic is encapsulated. So just to remember, just to let you guys recall that if you see a packet capture at point number 3, the traffic is already encapsulated. You will all what you will see, the traffic has been encapsulated within 10.0.0.1 source to destination 10.0.0.2, because the traffic is already encapsulated and the real IP address 13.13.13.1 is no longer visible. Finally, the traffic is sent through the physical layer and arrives in the ESXi2, sent through the decapsulation engine, through the NSX virtual distributive switch through the distributed firewall and finally arrives at the web server. Over here, NSX also gave us three opportunities to perform packet capture. Option 1 is the uplink. Option 2 is the ether switch. And option 3 is the post DV filter. Again, uplink is if the output at uplink will give you an opportunity to understand what happens to the traffic before it hits the decapsulation engine. Option 2 is where it hits the traffic before it interacts with the NSX environment. And an opportunity 3 is where the traffic, where you can take the capture before it goes to the VM. So these three opportunities at the ESXi2 and ESXi1 can help us to understand how the traffic is being treated at both ESXi servers. Before we move on, guys, let's have a quick demo, quick 5 minutes demo to understand how the packet capture actually work. And after that, we will discuss the other troubleshooting options. Let me quickly bring up my lab. Where is it? Here it is. Yeah. So as I showed you guys, I have two ESXi servers, .191 and .192. CentOS is trying to communicate with web server. CentOS is hosted on 191, and it wants to talk to the web server that is sitting on 192. So these two guys want to talk to each other, and we want to perform packet captures. We'll go back to CentOS, which has an IP 13.13.1 sitting at 191. I will quickly log in on the ESXi server. 68.111.191. So I'm logging into ESXi 191. Root. And the first step to perform packet capture is to run a command. ESX stop and press N key and try to identify the port ID. So port IDs are nothing but how ESXi server, where it is running so many images, so many VMs, how ESXi server can identify CentOS operating system through a port ID. This. So I will open Notepad and paste this port ID in it for reference. Click close, and finally I will go back on my and try to use my command. I'm a bit lazy, so so I will try to copy the command from my slides, and I will change the port ID from the slides, and I think it was 888.1. You can get the copy of the slides from the description section below. TCP dump, ENR, and press enter. Perfect. I will get back, log in on this CentOS server. And try to ping ifconfig. It indeed has an IP 13.13.13.1. And we're trying to ping 12.12.2, and it is reachable. If I go back, and it is indeed capturing the output. Perfect. So just to remind what we have done so far, we have taken the packet captures only on VNIC TX1. That is the traffic coming from CentOS before it hits the DFW firewall. Now we will take a packet capture or port output this point after the traffic has came out of the NSX engine, which includes DFW and NSX-based virtual distributive switch. We'll go back, copy the output from slides, paste it in my CLI. Yeah. Okay. I think I need to change the ID to .1. And TCP dump, ENR, enter. And reinitiate the packet captures, and we should be able to see the packet output. Perfect. So we have successfully captured the packet traffic at point number 2. So what we have done so far, again, just want to recap. Now we have taken the packet capture at point number 2. That is after the traffic has came out of network virtual distributed switch, and at this point. Now, what we will do, guys, we'll take packet capture at uplink. This is the capture point, uplink capture point. Just want to remind, this uplink capture point is the point where the traffic is already encapsulated. So at this point, you will no longer see 13.13, 13.1 trying to talk to 12.12.12.2 like we were seeing over here. Why? Because the traffic is already encapsulated using the TEP IPs through Genevieve. Great. So how to do that? We need to log in into our NSX manager. We can directly connect it from here. That logical switch. So go back to your ESXi vCenter and go to network and check the NIC. So I'm using segment which is blue. So in my case, and this is the VNI ID. Using this one, my job is done from NSX. And finally, I can go back and try to initiate the packet capture. I will copy the command from my slide. It's a bit easy for me. Yeah, here it go. So I just have to only replace the VNID. In my case, the VNID was 73729. I will copy, paste it. And TCP dump, tab, ENR. It's running. I'll go back on CentOS and reinitiate the packet capture one last time. Go back, and it does show us the output. But if you have noticed, the output was a little different, because in previous outputs, we could see 12.12 is trying to communicate to 13.13. But over here, this guy is trying to talk to each other over Genevieve, which is encapsulated between the TEP IPs. Bit different, right? So you need to mind it what kind of traffic you can expect when you run a TCP dump, at which capture points. The last thing which I want to cover for this packet capture thing is how to take packet capture in a PCAP format, which you can later open in Wireshark. So the first thing first, you go back. You should go back on your ESXi or vCenter, click the storage, and verify your ESXi host. What are the storage folder names? And go back to your root drive and cd vmfs volumes ls. So guys, just want to remind you, don't use my commands from my slides directly. It might differ. It might differ in your setup. So I've seen some cases the name of data store is changed from data store 1 to db1, ds1. So it's better you verify either from your vCenter GUI or CLI. All right, CentOS. Yeah, we can see that we are in the right drive. As you can see, we can see these outputs over here. Fine, I will do pwd, copy the drive location, and finally going back, we will again take this one last packet capture. So I'm going to take packet capture at port output. So what does it mean that I'm going to take packet capture after the port output? That which means that when the traffic is already came out of the NSX engine, and when the traffic is already went through the DFW firewall, the traffic has already went through the NSX-based virtual distributive switch, and we're going to take packet capture and we're going to open it in Wireshark. Let's get it done. In this case, I think I need to remodify the switch port ID. I think it was 1. And now I won't use Wireshark. I have to give a location name. The location name should be press enter. Now I will ask CentOS, I will initiate ping command one more time. 2, 3, 4, 5. Enough. I will go back. And if I go back, it should CentOS file. See, and I'll try to download this file. See, now we can see the packet captures which were exchanged at capture point port output. And we can see this capture over a Wireshark capture file. It's pretty easy. So it's not, and I think you have to use those capture points very wisely, guys, so that you can actually troubleshoot a problem in your environment. So that these capture points are very important. If you know what capture points you are targeting, so that it will be easy for you to troubleshoot the issues. We'll move on and we'll discuss the second technique, which is trace flow. So trace flow is a technique which you can access it from your NSX manager through GUI, where you provide the VM name, the source VM name, destination VM name, the protocols, TCP, ICMP, what kind of traffic you are looking like, and it will give you a simulation whether the traffic from CentOS will actually reach the web server or not. So in that case, even if you don't have access to the VMs, through this mechanism, you can actually troubleshoot if there is a problem from source to the destination. Trust me, this tool is very handy when it comes to troubleshooting. And from here, once the flow is completed, you can actually see how the flows are connected. In my case, I'm using a tier 1 gateway to allow blue segment talk to the red segment, and these are my VMs. I will quickly give you a demonstration. Back, trace flows, nice and easy. Our source will be my CentOS. Destination would be my web server. I will keep it as ICMP. I click trace. I absolutely like this tool. Trace flow is amazing because it gives you not only detail about the output, it also gives you visual representation. See, the CentOS is connected to tier 1 gateway. These are the blue and red segments and how they're connected. And you can see these are the observations. And finally, the traffic is delivered. There are no packet being dropped. Nice. We'll move on to the next topic. So the last topic for today is the live logs, where we can actually log in on the ESXi server and see what kind of traffic has been sent while you are troubleshooting an issue. I will go back on the CLI. The command is there. I think I have already given you the command on the slide. I'm pasting it over the CLI. And you can see that I've been trying to do some command, sending some command over here, ICMP. So this live logs is very easy, and it will give you a very good overview about how the traffic has been sent from source to the destination. That's it for this time, guys, and I hope this session has been informative. And please leave your comments in the description section, and you can get hold of the slides from the description section within this video. And I thank you for joining, and I hope the session was informative. Thank you.